Hi everyone, welcome back. Today we're doing longest palindromic substring. This is a question in the Grind 75 series, and to recap, the Grind 75 series are a set of questions that are meant to encapsulate most problem spaces that you will see in technical interviews. For this question, we'll be exploring strings and how we can solve string-related questions using sliding windows or other tactics. So for this question, we're given a string S, and we have to return the longest palindromic substring in S. For our viewers that are new to the concept of a palindromic substring, a palindrome is a string where if you spell it forwards and backwards, it will give you back the same representation. So for example, two examples of palindromic substrings would be ABA. In this case, if you spell ABA forward and backwards, that will still give you back the same representation. And even length AA is also considered a palindrome, similarly because it's the same if you read it from the front or from the back. So to solve this question, we can do a linear scan across each characters inside this S over here. And for each of these characters, we can take them as the potential center for a given palindrome. We can then start to expand outwards and check whether if that is a valid palindrome. And if that is a valid palindrome, we can also keep track of an existing variable that keeps track of the longest substring that we have. And if this current palindrome is longer than the current longest palindrome, then we will just replace that. So this is pretty much the idea for this approach over here. So with that, let's get started. The first step will be to define a longest palindrome variable to keep track of the longest palindrome thus far. So let's call this longest, and let's set this to the first character in this given string S over here. In this case, we can set that to the first character because we are guaranteed for S to be at least of length 1. So now that we have this convenience variable, we can start doing the linear scan and start expanding out the palindrome using the current index as the center. So for current index in range length of S, we can then proceed to use this index to expand out the palindrome. So to reduce the chances of errors and also to improve readability, I'll be defining two functions called getOddPalindrome. This getOddPalindrome function will take in the current index and it will do exactly what we plan to do. We will try to expand out a palindrome using this current index as the center, and if it finds a palindrome that is longer than the longest string that we have on line 8, it will replace that. And similarly, in this case, we will also do getEvenPalindrome, and we will pass in the current index as well. So once we're done, we will just return the longest string over here, and we're done for the day. Now the next step will be to define the two functions that we just defined on line 13 and line 14. Let's define getOddPalindrome. GetOddPalindrome will take in a current index and it will return back nothing. It will just do a mutation on line 8 if it happens to find a palindrome that is longer than what we have found thus far. So for the strategy of expanding out from the index to get an odd length palindrome, the strategy would be pretty simple. The strategy is to check the current left and right neighbors of the current center index and check if they are equal to one another. And if they are equal to one another, then we will officially set them as the new sliding window left and right indexes that represents this current odd palindrome. And we will recursively continue to expand out this window until we can no longer do that. And finally, once that is done, we'll check the current length and update longest if necessary. So let's start implementing this function over here. I'll first define a left index. This left index represents the left side of this sliding window, and I'll set this to index. I'll also set the right index to be equals to index as well. And we will officially update left and right if we are sure that this current new left and right index are really a valid palindrome. So now the next step will be to define pleft. Let's call pleft is an alias for potential left. So over here, currently, we're not sure if pleft or pright, which we'll define later, can be a valid expansion for this current palindrome. So to do that, we will first get pleft and pright first. For p left, we will set this to s at left index minus 1 if left index is more than or equals to 0, else we'll assign this to an empty string. So notice that this additional check here is to ensure that we do not go out of bounds. Otherwise, we will get an out of bounds index error over here when we try to access, let's say, a negative number in S. In Python, that's actually allowed, but that will give us obscure bugs, so we do not want that. Similarly, for this potential right character to be included in the odd palindrome, this will be equals to right index plus 1 if right index plus 1 is less than the length of S, else empty string. So now that we get these potential left and right characters to be checked, we can do while p left and p right and p left equals to p right. This condition on line 16 checks whether if the left and right characters are not empty strings. So if the left and right characters are not empty string and left character is equals to right character, then in this case, these potential left and potential right characters are actually valid expansions of the current odd palindrome. So what we can do is set the left index to minus equals 1 and right index to plus equals 1. So it will just take on the same index of p left and p right. And similarly, in this case, we will then proceed to prepare p left for the next potential expansion. So left index minus 1 if left index, I see, I made a mistake over here. I missed out the minus 1 in the check. So if left index minus 1 is more than or equals to 0, else empty string p right is equals to s is equals to the index at right index plus 1 if right index plus 1 is less than length of s, else empty string. So this will just keep playing until we no longer have a valid expansion where the left and the right characters are equal to each other. So at this point on line 22, we have left index and right index pointing at a valid odd length palindrome. So our job now is to check the current length of this palindrome and update longest if necessary. So one additional detail I missed out is that because this longest variable on line 8 is outside of this inner function, we have to declare it as non-local so that the Python interpreter knows that it should refer to line 8 instead. So over here, we are ready to check the current length of the palindrome. So current length, let's set this to be equals to right index minus left index plus 1. And to give more clarity, let's say if you're given a string ABA, the left index will be equals to 0, right index will be equals to 2. And notice that if you do right index minus left index, that's give us 2 minus 0 plus 1. This will give us a length of 3, which corresponds with the length of a given palindrome. So this is to clear up any ambiguity in why we define the current length as this expression. So now we can check if current length is more than longest. And what this means is if this current palindrome that we found is more than the longest palindrome that we have, sorry, this should be length of the longest, then we will set the longest to be equals to string at left index to right index plus 1. So we slice the string to get only the palindrome, the current odd length palindrome that we have, and assign this to longest over here. And at this point, we are done with this implementation. Let's do a quick check to ensure that we didn't make any typos. So left index is set correctly. Same for the right index. We set p left to be equals to the character to the left of the current left index that we have in preparations for trying to expand the palindrome outwards. We do a valid check for out of bounds for left index minus 1 before we try to access it in this string. Same for p right. We check if this expression is less than length s. And we perform the check for whether if the two potential left and right characters are part of this new palindrome before we officially update the left and right index for this given palindrome. And similarly, in this case, we do the same check for p left and p right in preparation for the next expansion on line 17. We then get the current length of the current palindrome and we update the longest string if this current odd length palindrome is longer than the current one. So looks great. let's do get even palindrome, and let's set this to have the same function signature as get odd palindrome. And the difference between this function and this function on line 10 is that before we do the expansion of the window, we will first check if the neighbor to the right of this current index is the same character as this current index. So for example, if you have AA, we will first check whether if this current right character is the same as this current character over here. So let's say we're given a palindrome like this, we will just check this first, this right character here first, before we try to expand the palindrome window outwards. So I hope that gives some clarity and we're ready to start implementing this function. So similarly, we will define non-local longest. We'll set the left index to be equals to, actually let's not set the left index first. Let's do p left will be equals to s index. Index if index is more than equals to 0, else empty string. P right will be equals to s index plus 1 if index plus 1 is less than length of s, else empty string. And over here, if p left and p right, and p left is equals to p right, in this case, if these two characters are really equal to one another, then we will officially set the left index to be equals to the current index and the right index to be equals to index plus 1. So after we are sure that these two characters are the same, then we will officially set the left and right index to these two valid indexes. So now, similarly in this case, we will do the same old expansion until we can no longer expand any further. So p left will be equals to s at left index minus 1 if left index minus 1 is it's more than equals to 0, else empty string. And similarly, potential right will be equals to right index plus 1 if right index plus 1 is less than length of s, else empty string. And similarly in this case, we will just proceed to do the same old expansion. While p left and p right and p left is equals to p right, then we will set left index to be minus equals 1, right index will be plus equals 1, and p left will similarly be updated to the next potential left, and p right will be expanded out to the right further with the same expression over here. So from this point onwards, the implementation is exactly the same as odd palindrome. We would just check if the current length is more than the current longest palindrome and update it if necessary. So in this case, if current length is more than length of longest, then we will set the longest palindrome to be equals to left index to right index plus 1. So yep, we're done. So let's quickly trace this as usual and see if this works out. So p left is equals to s index if index more than equals to 0, else this. Okay, the check looks correct for the first step. And if this left and right potential characters are the same, if a is equals to a, then only then we will start to proceed to expand out the palindrome. So we set left index to be equals to the current index and right index to be equals to index plus 1. And we will then proceed to expand out the palindrome as usual, just like what we see in get odd palindrome. So looks great. Looks great. Yep, this implementation looks great. And to ensure that this is right, let's try tracing this. Let's try tracing out this implementation using two simple test cases, odd length and even length test case over here. So let s be equals to ABA. And the second test case will be when s is equals to BAAB. So let's try tracing this test case first. So let's do it. The first character, in this case, longest will be set to A because we set it as the first character in ABA. And let's, for index in range length S, length s will be 3. So this will range from index equals to 0 to index equals to 2. So let's do get odd palindrome for the first character, which is a. So this will get invoked first. Index will be equals to 0, left index will be equals to 0, right index will be equals to 0. Left index minus 1 will be equals to 0 minus 1. So in this case, this would be assigned to an empty string. And this will be assigned to right index plus 1. So this will be s at index 1, giving us b. So p left will be an empty string. And p right would be b. So p left will be false because this is an empty string, so this will not run. So now the current length will be equals to right index minus left index plus 1, so this will give us 0 minus 0 plus 1, giving us 0. So if current length is equals to 0, is 0 more than length of longest, which is 1? In this case, that's not true, so this is false and nothing happens. So we're done with the first iteration. Okay, let's remove the traces and let's continue with the second character. For even palindrome, or even palindrome will be invoked for index 0 as well. So let's trace this as well. This will give us back a. Sorry, this gives us back string at index 0. So this gives us back a. And p right in this case will be 0 plus 1. So in this case, this will give us the character at b. So this will give us back b. If p left and p right, and p left is equals to p right, well, p left is not equals to p right, so this will terminate and the whole function terminates, and we're done with one iteration. So we'll do it for b. We don't really have to do it for the final character because the first trace for a would be the same as the final trace for a. So let's trace b over here. So we will first get the odd palindrome. So we can see that left index in this case will be equals to 1, right index will be equals to 1. So p left will be equals to 1 minus 0. So this will give us back, p left will give us back a, and p right will give us back a as well. So 1 plus 1, so in that character index 2, so giving us back a. So while p left and p right, p left and p right is indeed a, and p left is equals to p right. So this is true. We will start going to line 18 and line 19. We will set left index to be equals to 0 and right index to be equals to 2. And in this case, we will try left index. In this case, left index will be 0 minus 1. This will be false, so this will be an empty string. P right will be equals to 2 plus 1. Well, 2 plus 1 is 3. 3 is now less than length s. This will be false. So this will give us an empty string as well. And because p left and p right are empty strings, the next iteration of while loop will not execute. And now we're at line 23. Current length will be equals to 2 minus 0 plus 1, giving us 3. And because the current length of 3 is indeed more than the length of longest, in this case, this is just storing a at the moment. So this will be 3 more than 1. This is true, and the longest palindrome string on line 8 will be set to the current odd length palindrome string ABA. So that's pretty much the end of this trace, and this looks like it works correctly. For even palindrome, let's not do that. We roughly can see what we will get if we trace this out. So this is a little sneak peek to how we can ensure our implementation is right without a Python interpreter. In some technical interviews, we do not have the luxury of being able to test out our code. So I hope that this tracing session gave you a little insight into how you should ensure that your current implementation is free of errors. So now let's try running this against some sample test cases. This passes, and let's submit this. and this passes the test cases, luckily. It's very possible for you to trace this out and still end up with errors. So in this case, we're lucky that we didn't make any mistakes while tracing, so this passed the test case. So the time complexity in this case, if n is the length of s, then the time complexity will be O(n) squared. And the reason why is because we do a first linear scan on line 49, so this is O(n). And within each index over here, we do expansions for get odd and get even over here as well. So this is an O(n) on top of every single index in this iteration. So this gives us back an expression of O(n) squared. For space complexity in this case, we kept track of a string variable that represents the longest substring. So in this case, the space complexity, if we include the space used on line 12, then this will be O(n). If you wish to optimize this further and do the string slicing at the end, you would still use space for that final slice string, but you can keep track of the left index and the right index of the current longest palindrome string as well. But you should still end up with a space complexity of O(n). But if you wish to exclude out the space used to return the substring, then you can say that this space complexity is O(1). So that's pretty much it for this implementation. I hope that this was a clear trace of how we will implement a Leetcode implementation, and I hope to see you in the subsequent videos. If you find this useful, please give us a like and subscribe, and we will see you in the next video.